Hello, dear friends. I hope you people will be fine and enjoying a very sound health. Today, I am going to upload another interesting and informative video tutorial related to simulation of perovskite solar cells in SCAPs 1D. In this video tutorial, I would like to show you how we can extract simulation data in order to plot any particular graph in Origin software or Microsoft Excel. So first of all, I would like to share my screen with all of you so that I can start for today's work. Okay, dear friends, you can see that I have just shared my screen. Now I'm going to start about my content about today's work. So probably when we are going to start a simulation in SCAPs 1D, we have this first interface, basic interface. And from beginning, I would like to add some more information for particularly those students who are going to start from the beginner. So when we are going to start simulation for any particular solar cells or perovskite solar cells, we need to mark this button from dark to light, because almost all the testing of solar cells and the perovskites are being conducted in the presence of illumination or light spectrum. In this video tutorial, I have just assumed that the series resistance of my structure is 1 ohm and the shunt resistance is about 1 raised power 6. So in this video, I would like to emphasize on two basic key analysis, like electrical analysis, that is known as JB characteristic analysis, and the optical analysis. Normally, we used to call it quantum analysis, quantum efficiency computation analysis, or inverted power conversion efficiency analysis. Both these analysis are very important for perovskite solar cells, like in case of computation of optical and electrical properties. And next important thing, a lot of students used to ask about this session, like what we need to write over V2 value, because this V2 value is normally used a little bit higher than that of our VOC computed value. And from literature, when we are going to use any particular perovskite, we can have some little bit idea about what would be the average value VOC, open circuit voltage value, of our particular perovskite. Like for tin, we know that it's about 0.8385, like that, but for lead it is higher than that of 1. So just I'm going to put over here 1 volt, so that my simulation will be stopped upon reaching this value, and the V1 is normally set as 0. So I just need to switch my screen to my basic structure so that I can start for my simulation work. Okay, you can see that now there is a basic structure over here. This is planar structure and IP structure. We know that normally we have planar or inverted structure in perovskite structures, and we use to simulate them depending upon their advantage and disadvantage. Now, in this video, I'm just focusing on planar structure, in which light is being incident from the bottom and it will pass from to glass, titanium dioxide, perovskite, methyl ammonium tin tribromide, and spirooctane. This is HTL, and this is ETL, and this is the protective glass, and this is the absorber layer. So basically, the structure has three interfaces. First one is basically the glass and ETL. Second one is basically ETL and the perovskite. And third one is basically perovskite and HTL. And now I'm going to start my simulation, particularly related to JV analysis and the QE analysis. And then I will show you how we can extract data from our particular these two analysis, and then how we can import data results from SCAPs to some external file, like we talk about the Excel file, in order to make a more progressive and compact graphical representations. So, okay, I'm going to start my simulation by clicking on single shot. I'm not using any batch setup analysis or record setup analysis. One person can use it, like in order to check the impact of the thickness on performance parameter and other analysis as well. I'm just focusing on optoelectrical analysis for this kind of structure and this simulation work. Okay, I just started my simulation work. These two analyses are very important in order to check either we have used parametric values accurately, like if we are going to simulate JV characteristic curve and QE analysis curve, and we are not getting any convergence error, it means we have used the performance parametric values for structures accurately. Now my simulation has been computed. I need to show, first of all, IV characteristic curve. Okay, you can see that this is exponentially increasing curve, and below over here is basically the performance parameter, one of the most important, VOC, short circuit, fill factor, and the eta efficiency analysis, efficiency, power conversion efficiency. Now I need to move the real content of my this simulation result towards the data computations. So in order to compute this data, we need to click over here, show. Okay, you can see that we have a lot of computations over here. And from here, we can see that this is the voltage column and this is the current column. And other parametric values are like ring combination current and other parameters. But we are not interested in other columns. What we need to do, how we need to extract this data, we need to just mark this with Control C, copy, and then we can paste it in some Excel file. So just I'm interested in computation of JV characteristic curve. I will keep first column and the second column, and I will remove all other pending columns. And then I can use this data for plottation of graph in Excel, or as well as in Origin. In my next video, I would like to show you how we can compute fundamental basic graphical representation using simulation data in Origin software. So next thing is that I need to go back, and similarly, I can click on quantum efficiency analysis over here. You can see that this curve is basically the quantum efficiency analysis curve, normally known as the optical analysis of perovskite solar cell, in which we can compute the how much incident photons were incidented on perovskite and how much number of electrons and holes were produced. So this is called inverted photon conversion efficiency as well. Now I need to once again mark this button as show. Okay, now we can see that we have data over here, a wavelength, quantum efficiency, and we need to do the same procedure. We need to just copy this data by using Control C, and we can import this data in some Excel file by just Control V shortly. So in this way, we will export our this simulation data from SCAPs 1D simulation tool to some other file like Excel file and other software as well. So next, in the end, I would like to add some important answers related to some comments that were seen by me in recently some of my video tutorials, and I would like to address all these comments in this video session. Like some students used to ask about some main important things. What is the main role of this ETL and this HTL? Like typically we know that this ETL material is used to extract a large number of electrons that has been generated by this absorber layer, and this HTL material is basically used to extract large number of holes towards positive end of the perovskite solar cell. But there are some questions related to light incidents, and there are some questions related to some more electrical properties of HTL and ETL. When we are going to select a particular ETL and HTL, one student need to do a little bit research in terms of what, like we need to select such ETL materials that has large admittance, and we need to find such HTL materials that has large reflectance, because admittance and reflectance both are opposite to each other. We are more interested that the large number of incident rays were basically absorbed by this absorber layer, and we are more interested in selection of such HTL materials that can reflect back the number of incident rays towards the absorber layer, because most of the light that is being incident from the bottom, either from the top of the structure, used to waste by passing through the structure without absorbing this into this absorber layer. So we must have ETL material that has large admittance values, and we must have HTL material that would have more absorbance, reflectance values. Normally, some people also use over here some coating layer over here in order to reflect back these incident lights rays towards the absorber layer. So in this way, we could have more better efficiency, we could have more better performance parameters and stability of the structure. In the next video, I would like to show you how we can plot basic structure in SCAPs 1D, because SCAPs is one of the most leading software that normally researchers and students are using these days in order to extract accurate graph for publication of their papers. And I will use this data for the graph computation purpose as well. So I hope this brief session will be helpful for those students who are looking for the answers, how we can compute data from SCAPs 1D simulation, and how we can import this simulation data from SCAPs towards other software like Microsoft Excel and others software as well. Thank you very much for listening me and supporting me. Take care. Allah Hafiz.